Simplifying rational functions. Very similar to what we were doing before. The only difference is, and now we have separate rational functions. We have one here, one on this side of an equal sign, and then we have a subtraction sign in between. In all of our previous rational functions, do you remember what they were all equal to? We set them equal to something all the time. 0. We're going to do the same thing. We're going to move this guy over to this side of the equation. So he's positive here. So when he comes to this side, he's just going to become negative. Okay, so we'll rewrite this. This will now read 0 is equal to 5a plus 7, right, minus 2a minus 3 minus a minus 30 divided by a squared plus 4a minus 21. Now there's a couple things we need to do here. In order to add and subtract, these are all fractions, right? In order to, in this case, subtract them, we have to have common denominators, and none of the denominators are the same. Okay, now, just as a trick, I can actually very simply get this denominator and this denominator to be the same, but this guy here I want to factor first. So I'm going to factor them, see what we get, and then work to change these, okay? Let's try to make sure we're always in simplest form before we start changing them. So these two are already in simplest form. There is no factoring of it. We're going to look at the denominator of our last term. So I'll do him in green. A squared plus 4a minus 21. We're going to focus on that guy right now. Okay? And when we focus on him, we're going to factor him. Okay?
It's going to be that.
It probably is. Most likely in these types of questions, they tend to make them easier like this. So we have a squared plus 4a minus 21. Well, because this is a 1 term, we're just looking for two numbers that multiply to negative 21 and add to positive 4, which is our middle term.
7 and negative 3.
Perfect. So 7, negative 3 works. And because it's like that, we don't have to go through the big, long decomposition. It just becomes a plus 7, a minus 3. Great. Those are two of the terms we have up here. So we factored this. I'm going to rewrite it. 0 equals 5, a plus 7 minus 2, a minus 3 minus a minus 30 divided by, and this one becomes a plus 7, a minus 3. So that kind of actually gives us a hint to what we want our other denominators to be, right? This one has an a plus 7, so does he, and this guy has an a minus 3, so does he. So this is the denominator we're essentially looking for. In order to make these denominators that way, what we're going to do is multiply the top and the bottom of each of the fractions, right?
A minus 3.
Exactly. I'm going to multiply this guy by a minus 3, both the top and bottom. And we're going to multiply this guy by a plus 7. Exactly. Good. And then those come in brackets. So let's rewrite it again. 0 is equal to 5 times a minus 3 divided by, and then we have our common denominator, a plus 7, a minus 3, minus 2 times a plus 7 divided by, same denominator again, a plus 7, a minus 3, and finally subtract a minus 30 divided by, again, the common denominator. Now, when you have a common denominator for fractions, what is your answer's denominator going to be? Do you recall? When you combine them all, for instance, I'm just going to do a little side thing here. If we had 3 over 5 minus 2 over 5, the answer is going to be over what?
5.
5. It's going to be the same, right? And then what we do is we actually just subtract the top. 3 minus 2 is 1. So we know our answer is going to be very simple. 0 is equal to, or our denominator is just going to be
a plus 7
and a minus 3. So that makes the bottom very easy. Now what we're going to do is the tops we're going to subtract by each other.
Or don't we have to distribute them first?
We will have to distribute those negatives. We also don't, well, yeah, we can distribute the 5s, or sorry, not the 5s, but the coefficients. Let's see if we think it's going to help us first. Let me quickly look at it. Yeah, you're right. We're going to have to distribute them. So let's distribute each of these terms and subtract in the same movement, okay? So 5 times a gives us what?
5a.
Okay, and 5 times negative 3?
Negative 15.
Okay. Subtract 2 times a?
2a.
2 times 7?
14.
Subtract a minus 30. Okay, and we'll just extend this line.
And then don't we put the like terms together after that?
Huh? Well, we do have to also distribute still. We have to distribute this negative to both of them inside. Okay, so when we do that, 0 equals, denominator does not change. Still the same. Then we distribute these, we can get 5a minus 15, subtract 2a minus 14, subtract a plus 30. It changed all the operations, right? Collect like terms. We have these a's, and we have these constants. When we do that,
Negative 2a.
yeah, so 5a minus 2a is 3a, 2a. Good. Negative 15 minus 14 is negative 29 plus 30 is positive 1. Okay?
Yeah.
So it's a plus 7, a minus 3. Is that right? Let me just double check.
Yeah, that's right.
3. Yep. Okay, I can't common factor this guy. No, he's not a difference of squares, it's an addition. So this is factored as far as it goes. There's not much more to simplify. All we got to do is state the restriction. So a plus 7 cannot be 0, so a cannot be what?
Negative 7.
Yeah, and a minus 3 cannot be 0, so a cannot be
3.
3. That's it. We simplified it, and we've got our, we've stated our restriction. Again, quite a bit of work to doing that. The key is making sure our denominators are the same when we go to add and subtract.